Welcome to homework.
Okay. Um, so yeah, this is a pretty tricky one. I'm reading. Okay, do not understand chemoselectivity, regioselectivity, stereoselectivity, and changes in oxidation state. Well, there's no stereoselectivity here, but I'll step you through the synthesis. First thing, I'm just gonna simplify things a little bit and just say, um, we can just focus on a molecule like this because nothing on the right is going to matter. Like nothing out here matters. What does matter? So we've got this here, and then we've got a pair of methyls here and an OH here, right? And ultimately, we know we need to break this bond, right? Well, what carbon-carbon bonds do we know how to break? Do we ever see carbon-carbon bonds breaking in any context? It doesn't happen often, right? We don't really ever do that. And the reason for that is that, most of the reactions we know, there's like, oh, maybe a leaving group, right? And we'll break a bond. But we don't often see carbon-carbon bonds breaking because carbon's never a good leaving group. Well, the tricky thing is that the bond we do know how to break is a double bond, a carbon carbon double bond, right? Because if we use ozone, right, we know we can do ozonolysis, right? So if we can turn this into a double bond, then yeah, we can do ozonolysis basically, right? We could break this bond, and that's actually kind of nice, right? Because imagine that we did have a double bond there, right? And we do ozonolysis, we get something like this. Okay, we know how to reduce those into alcohols, which is another part of what we need to do, right? Eventually, we need to have alcohols, right? Because our product, I guess let me draw the product again real quick. Well, let me just take that. Right. So what we're trying to do is this, right? And that looks like that to me, right? So hopefully you can see how it is I got to this answer, but we can step through it and I'll try to explain the regioselectivity and the stereoselectivity. Well, the first thing you may notice is that we need to form a double bond between this carbon and this carbon. And we're kind of lucky in that regard because we don't want to form a double bond here and we don't want to form a double bond here. But what do we know about double bonds, right? We need to lose a neighboring hydrogen, and there aren't any hydrogens here. That's a quaternary carbon. There aren't any hydrogens here. That's a quaternary carbon. So if we were to use some acid and heat or sulfuric acid and heat to affect an elimination reaction here, it can only happen on one side. So we're in luck in that regard. That's, I guess, probably what they mean by, regioselectivity, right? Um, and we know we want to make a double bond because if that's the only way we know how to break carbon-carbon bonds, right? So let's just say H2SO4 aqueous and heat favors elimination reactions, right? Um, okay. And we'll get our double bond here. Okay, not too bad. And then at this point, we can do our ozonolysis. Okay, and I'm going to copy this again, right? Ozonolysis, I like to think of it as like scissors that leave behind oxygen. You just slice that in half and leave an oxygen on either side, synthetically anyway. That's not at all like what really happens. The other thing I'm going to do is I'm going to swing this double bond out. Um, Yeah, I'm going to swing the double bond out so that it's not in the way. Okay, so ozonolysis, we know we're installing a double bond to oxygen here. And then this will swing out and we'll install our double bond to oxygen here. And at this point, all we've got to do is reduce a ketone to an alcohol and reduce a aldehyde to an alcohol. That's not too bad. We know how to do that, right? There's a few different options. I think lithium aluminum hydride should work fine. Okay. I think we could probably there's a milder one that we could use. Like this will reduce, I think this is like the strongest reducing agent, right? So it would reduce like carboxylic acids and stuff. This may be overkill, but it will work, right? So that's the important part. Right, so at that point, we're done, right? Yeah. Changes in oxidation state, right? Oxidation reaction. This is a reduction. This is installing alkene because we need to break a C bond. This alkene will form regioselectively due to neighboring, I'll say other neighboring carbons being quaternary. Yeah. Okay, that's it.